Ladies and gentlemen, the presentation that you're about to watch, hopefully to the end, was first presented on a seminar arranged by James V. Jones in late February 2024. The aim of the seminar was to bring together a bunch of, let's call them the older hands in the ILS support engineering industry, to discuss the issues and the problems, the challenges and so on, and potentially the benefits of converting from an ILS, integrated logistics support approach to support engineering to one based on the IPS approach, integrated product support. The approach I determined to take on this one was to basically address the impact of adopting the ASD S series of support engineering product support specifications, with a particular focus on the data aspects, as you'll see shortly. So that's what you'll see on the following slides. Before we start that, though, best I give you a brief introduction to myself. Obviously, I'm Peter Stuttard, and I've been in this industry for over 30 years now. And if I count my service career, I was an engineer, an aircraft engineer in the Army, then it's perilously close to 50 years, which is kind of frightening. But anyway, on with the show, adopting the S series. Now, ILS or IPS is more than just the implementation of a bunch of specifications. There's a lot more to it than that. But my personal perspective is that there is very little difference between ILS and IPS if you take out the S series of specifications. One is simply a restructuring or restating of the other. Cynic would say, in fact, that what we're trying to do with IPS is to persuade people to do all the things they should have been doing when they were doing ILS. But there is a problem, of course, and that is that if an organisation was paying lip service to ILS, then they'll pay lip service to IPS as well, in which case the specifications won't help. So whatever happens with this, whether we call it ILS or IPS moving forward, unless the leadership basically gets behind these ideas, then we'll not actually make any real progress. Now, because of that, I decided, and particularly this is true in the UK, the big change is actually a change of specifications, moving from old standards like DEF standard 0060 in the UK or 1388 to B if you're talking about data standards, moving on to these new ASD S series specifications, which have all of them, well, there's a lot of them, have their own data standards. I will also talk about processes to a degree, a lesser degree, and you see that particularly comes in towards the end, because at the end of the day, data only exists for two reasons, if you like. One is to basically document processes, and the other is to document the results of those processes, the products. So basically, we need to document ILS or IPS process, and we need to document ILS or IPS outputs, products, and so on. So the focus of my presentation is going to be on data in this instance. Okay, so what we're going to talk about are what are the issues. There's a range of issues which you're going to have to overcome if you're going to want to move from the old ILS standards to the new S-series standards. Now, the experience that we've gained and the things I'm going to talk about basically comes from two sources, essentially. One, Aspire has developed a range of training material for the S-series specifications, which we presented to both foreign MODs, overseas MODs, and a number of major contractors. Now, if you're going to do that, one of the things you have to do is you have to study these standards in great detail. In other words, you've got to know them inside out in order to present them. So we gained a great deal of insights through that process. But the major source of our understanding here was we were working on a very large capital equipment project in the UK, which was looking to move from the old standards, in this case, DEF standard 0060, which is part 0, that is, where the LSAR, the data standard, is basically defined, to S3000L and potentially other elements of the S series as well. 2000M, 4000P, and so on. And what we found was that there's actually a couple of projects in the UK where the requirement in the original requirement set imposed on the prime contractor was to actually use S3000L, the S-series specification for LSA, for logistic support analysis. In both cases, however, both projects had walked away from that. And if you ask them why, in simple terms, they'd say, well, we just kept on running into brick walls. So what we found is then they abandoned their 3000L and went back to using DEF standard 0060 Part 0. Now DEF standard 0060 Part 0 is a standard which was cancelled in 2010. So it's been basically cancelled for the best part of 14 years now, but we're still using it. And what we've got to do is we've got to ask ourselves in some detail why. What are these barriers which are causing people or organisations and projects to walk away from using the new standards and sticking with the old ones? And if we can understand that, then we know what issues we're going to have to overcome to move forward. Now, one of the first problems which becomes clear fairly quickly is the sheer number of organisations which all have to move at the same time in order to translate from one set of standards or specifications to another. This diagram I've shown you here is just one I pinched from a previous presentation, and it represents a major project because, as you can see on this diagram, I've got the end user, of course, the customer, the guys in the blue or the green baggy suits who actually have to use this kit at the end of the day and to maintain it. You've got the actual agency, which is going to actually be doing the procurement. In the UK's case, this is DE&S, of course. And within that agency, you've got a procurement team, a project team. And if it's a major project, a big project, and the example I'm thinking of at the minute was a major project, you will have a systems integrator who's going to perhaps bring together the outputs of a series of prime contractors. I appreciate not all projects are this big, and some may only have a single prime contractor. But then below those prime contractors are a number of suppliers, second and third tier and even fourth tier suppliers who are providing equipment, information and support ILS products, IPS products, which is tech pubs and maintenance plans and training materials and so on, into the system. And there may be hundreds, if not thousands sometimes, of those suppliers. And here's the problem. What we want them to be doing, of course, is using some sort of common tools and processes. And underpinning that lot will be a common set of data as well. And they all need to be using the same thing, of course. Otherwise, we're going to have huge problems. There is other issues as well. There's other projects surrounding these major projects. Very often, they may be part of a family of equipments, a family of platforms. And those other platforms will be using the old standards as well. They will have data in the old standards format. The new project may need to utilise. They may also have lots and lots of shared facilities, and shared IT systems and so on, particularly when they get into the in-service phase. So you do have to think about what other projects are out there. The other thing is as well, the existing software that we've got, which is implementing these data standards, interfaces with a whole range of other applications. So you'll find that major contractors have PLM or PDM systems, and their ILS tools will interface with those. They will share data, share product data, and configuration data, and so on. And we're going to come along and say, well, implementing a whole new series of data standards, which will now not have the same sort of interface, the same sort of fit. So, having ascertained that everyone has to be singing from the same hymn sheet across a major project, and there's a lot of people involved, it's a huge number of people to move all at once. Here's the other problem. If we look at the S-series specifications, they're big. There's a lot of them. There are the 6 core standards, S1000D, 2000M, 3000L, 4000P, 5000F, 6000T, and I suppose we could count S10000I or SX000I if you prefer, as one of those major standards. Each and every one of those has got its own data model. And there are a number of supplementary standards as well, which provide guidance and so on to how to apply all these things. Now, if you tot up all the pages in that lot, fairly crude measure, I appreciate, but you're talking about well over 10,000 pages. And if you're going to implement these on a program, people have to read them. They have to do more than just read them. They have to read and understand them, and they have to interpret them, and they have to work out how they're going to apply them. And that's a big challenge. That's a lot of understanding, and you need a lot of people to have a lot of understanding of different areas. And it's not just a case of having one bunch of people who understand 2000M and another bunch of people who understand S3000L. You need people who understand the totality, because standards and data doesn't go forth and integrate itself. You need people who can actually cause that integration to actually occur. So there's a big organizational learning curve which you have to overcome. Now, there's another problem associated with these standards, and that is they keep evolving. I'm not going to stay on this slide too long because it'll make you feel seasick. But basically, they keep evolving. They keep moving. The last update to S3000L, for example, made some major changes to the way the data was managed. Now, think about the software houses who have to produce an application which basically implements these data standards. It's a challenge. Plus, it's a challenge for us when we're doing our training, for example, because you've put together a set of training materials, and then a couple of years later, people reissue the standards. You've got to go back and reread them and restudy them, spot the differences, and update all your training materials. Or sometimes, in actual fact, because different people, different organisations will be on different versions of the standard, you need to maintain several versions of the training material. So it is a challenge that these are a movable feast. You're trying to hit a moving target. Okay, so here's another problem: backwards compatibility. A lot of projects rely on the availability of data from previous projects. It's fairly normal. If you're building a large platform, you'll find that a lot of the equipment on your new platform is the same as or very similar to equipment on a previous platform. So you can actually reuse an awful lot of the information, and it's only sensible to do so when that is applicable. The problem is that the S series have not been prepared with any eye on backwards compatibility. Now, the magnitude of this particular problem became clear when on the major project that we're working on, we were looking at mapping the data required for that project, which was already moving, if you like. It was, I used to talk about this was changing the wheels on a moving bus problem, but that data was already being compiled. So what we did is we looked at the data as required by the project, which crudely was about 40% of that defined in Def Standard 0060 Part 0, and we mapped it onto one of three of the S series, because we couldn't simply map it onto one. So we were looking at the LSA standard for the MOD, Def Standard 0060, and mapping it onto S3000L, that's the data standard for LSA, to 2000M and the data standard for supply support, and onto S10000I, which is kind of, if you like, the overarching standard for ILS amongst the S series. All three, say, have got their own separate data model. So what we did is, I say, a comparison, a data element by data element comparison from one to the other. Okay, so this is what we found when we mapped the data, the 0060 data as required by the project, onto those three S series standards, S series specifications. And we did this data element by data element. We did a fairly crude categorization, if you like. So category 1 was simple. So basically we found a data element in 0060 which had a very obvious and single place to put it in one of those three S series. The priority was always S3000L, but when there was no appropriate home for the data in S3000L, we'd look at 2000M and S10000I. So category 1, simple, and as you can see the percentage there, about 21%. Bear in mind, say this is a subjective and crude assessment. Category 2 was where there are some issues, and there's a range of different issues. We put this into category 2. Things usually where there was perhaps two different places. You could put it in 2000M, you could put it in S3000L. So, maybe two different data elements that you could align something with in the S series. Category 3 was slightly more complex, where there's no exact match for the 0060 data, but possibly one or more of the attributes, and that's the term we use in the S series, the attributes there was possibly one or more that have a very similar sort of function that could be adopted, maybe adapted to use as a home for this data. Category 4 was very complex, where you'd have to do some really quite complex manoeuvring, if you like, and reinterpretation, and perhaps use a range of different data element, range of different cases and attributes in the S series to actually perform the same function as a data entry in 0060. And category 5 was there was just no match we could find anyway that would work for the 0060 data. There was nowhere to put it, basically. And it's worth noting those last two categories of complex and no match categories 4 and 5. If you look at the data there, you'll see there's 35 and 17% of those two categories. So a significant amount of data you're going to have a struggle with to find a home, if you like, for this historical data, for this legacy data that you may already have from previous projects. Now, here's another issue that if you're a practitioner working at the detailed level, you're going to have to overcome if you're starting to apply the S series. And that is the way the data modules are documented is completely different from the way you may be familiar with if you've been using Dev Standard 0060, Part 0, or 13882B, and so on. It's a different sort of data standard. It uses something called Unified Modeling Language, or it actually uses a very small portion of Unified Modeling Language to define the data models. And what I'm going to do is show you a couple of examples of that and try and explain some of the issues and some of the things you're going to have to familiarize yourself with as we go forward. Now, what you can see here on the screen is an example of the way the data model is defined, in this case in S3000L. Now, what you can see here is a thing called a unit of functionality. This is not actually part of UML, it's something that the S series have come up with, and it is roughly the equivalent of a set of tables in 1388 2B or 0060 Part 0, very roughly. And within this, you can see, hopefully you can see my mouse here, we have these things called cases, which are, again, very roughly the equivalent of a table, very, very roughly. And within them, you've got attributes, and the attribute is roughly the equivalent of a data element or data entry. And you can see in this particular example as here, this is an attribute group, a group of attributes, usually an extension to another particular case, just to make the documentation easier. And you can see the attribute group is the name of the attribute group and the name of the attribute use XML names, and they use this camel case convention to label those names. Now, what I want you to take notice of, and we'll expand this in a minute on another screen, is the fact that these have types. So you've got property type and descriptor type here. Right, so what we have to discuss here is this concept of compound attributes, and I've changed the title here, and I've expanded this particular case so you can see it a little bit more clearly. So this particular attribute, task frequency value here, which has got this property type, is not a single data element like you would expect to see in 13882B or 0060 Part 0. To understand it fully, what we have to do is we have to look at the definition of a property type, and to do that we go to a different standard, one of the supporting standards within the S series. Okay, so we need to understand what we mean by a property type, and the types are described in one of the supporting standards of the S series, in this case SX002 Delta. You can see at the top of the screen here, and what we can see here is that property type, first of all, it has some extra information on. You've got the actual value, and you've got a date type. So basically what it's saying is you can have a range of values in here, each with its own date time group associated with it, so you can see how that value changes over time. The other thing is that the value can actually have two different options. You can have a numerical value, or you can have a text value. So that would be something like as required. If you've got a numerical value in there, then you can have just a straightforward number, an integer, or you can have a value with tolerances, upper and lower tolerance limits, or you can have a range of values from to as an option. Now, what's missing off here is measurement base. Again, those of you familiar with 0 to 60, part 0, or 13x 2b, and so on, will know that when you've got any value, such as task frequency, it also comes along with an associated measurement base. So what's that task frequency? Flying hours, operating hours, some event number, like number of rounds fired, number of landings, and so on. It's not mentioned on this particular definition here, but it is mentioned in the text which is associated with it. Now, I suspect that's probably an error, and there should be measurement base built into here as well. But the point is, as you can see from this diagram, that it's not a simple metric. It's not a simple data element. It's a compound attribute. It's got a lot of supporting information. This means that if you're setting up a project and you're going to use task frequency, then you've got to determine which of these you're going to use and how you're going to use them. And that has to be common, of course, across all the people, all the individuals, all the organisations involved in the project. Now, also associated with this, there's lots of elements which have the property type, but one of the key ones is this, and I've used this just to make a point. There's a unit of functionality in S3000L called performance parameter. And the reason for this is that the latest version of S3000L does not have a data element for mean time between failure, or failure rate, or mean time to repair, and so on. What it does, they were all taken out at the last iteration. What it does provide is a mechanism for defining your own performance parameters, and that's basically what you're looking at here. And if you look at the bit I've highlighted on the screen there, you will see that it's also got that performance type, property type, sorry. So basically, you've got to decide what the performance parameters are, going to make them common across your project, and you've got to actually then, for each one of those, they've got this property type, so there's this quite complex structure behind those metrics, and you need to make sure, as I said before, that everyone is working to the same set of rules, same set of definitions for your metrics and so on. Okay, now on this slide, I've just listed a few things which are different from the old standards to the new standards, and you just have to be aware of these things. And there are more. I must emphasize that these are just examples that I'm presenting to you on this presentation. But there are things that you're going to have to take account of. So the first one is fairly straightforward, I think. Then that if you're looking at a 0 to 60 or 38X2B database, failure and damage modes use these things called failure mode indicators. So this is a failure mode indicator, FAAA. The letters are basically changed sequentially across the failure modes. And you can also define damage modes. So this is a damage mode indicator, TAAA here. S3000L doesn't use those failure mode indicators and damage mode indicators. It uses different approaches. And it has quite a sophisticated mechanism, if you like, for identifying the type of damage that may occur and the probability of that damage occurring as well. So in that instance, it's just different, and you're going to have to be aware of that difference and adapt to it when you're doing your analysis. Perhaps of slightly more significance is this one here, engineering failure mode MTBF. Basically, what we need to do is we need to understand how often each failure mode occurs. So we want a failure rate. Basically, invert the failure rate and you get MTBF. And the way that's calculated is quite simple. We take the failure rate of the candidate item, the things which got the failure modes, and we multiply it by a thing called a failure mode ratio. Now, just to illustrate that, if you're not familiar with it, a little black box may have 3 failure modes. Imagine it's just got 3, and we basically apply the failure mode ratio to each of those failure modes. So the first failure mode may have a ratio of 10%, 0.1. The second failure mode may have a ratio of 20%, 0.2, and the third failure mode may have the remainder of that, 70% of the time. That's what fails, so 0.7. So basically, when you add the failure mode ratios up, they've all got to add up to 100% or 1. And if you multiply that figure by the failure rate of the end item, you get up with a failure rate basically of each failure mode. Invert that, and you've got an MCBF. Okay. that's not what happens in 3000L. Yes, it's got failure modes defined. There is a case on those little boxes that we saw on the previous slides, which describes failure modes. Okay, not a problem. It's got an attribute called failure mode ratio. Again, great, not a problem. But there is no failure rate defined, and there's no MTBF defined. Remember from the previous couple of slides. So if you're going to use this, you're going to have to create the performance parameter failure rate first, and then you're going to have to build in a calculation, because the calculation is not defined either. It's a very simple one that multiplies that parent failure rate by the failure mode ratio to determine the failure rate of the individual failure modes. All right, so that mechanism is not there in S3000L. So if you need to use it, and I suggest you do need to use it, you're going to have to create it. And the final one on this particular example is this idea of technical and operational failures. And this basically allows us to understand the difference between a basic failure, sometimes called basic failure, technical failure, basic failure, and the cost of that, if you like, cost of repairing the system, and the impact on an operation or on a mission. And operational failures are sometimes referred to as mission failures. And where this comes into play is when typically you've got redundancy and backup systems. So if you imagine you've got a triplex system, let's just say 3 radio sets on a platform, and you've got 3 radio sets which operate in parallel, simply to give you a very, very low probability of losing the function to communicate over the duration of a mission, because you've got you've got basically redundancy in the system. Then you've got 2 figures you need to take into account. The first one is basic failure rate. Basically, if you put parallel systems in redundant systems, you've got more stuff to fail, so your failure rate will increase by putting redundancy, if it's active redundancy in particular. But your operational failure, your mission failure, your chances of the mission failing because you've lost the function to communicate has reduced. So those are the 2 different parameters, and we need to understand them, and they are almost essential if you're trying to look at operational availability and of course and the amount of resources you need to maintain that operational availability. There is no equivalent facility in S3000L. So if you want that, and I suggest you do, you would have to build it in yourself using those performance parameters I talked about earlier. And you'd have to make sure that everyone working on the project was working to the same set of definitions and using the same performance parameters and understood the relationship between them. Now there are other issues, and duplication between the different S-series specifications and their data models is one of the problems that we're going to have to overcome, or one of the issues to address. But probably worth making a point at this point in the presentation that the examples I'm showing you, I have shown you, and I'm going to show you, are based on a particular point in time, a particular version of those standards. So just bear that in mind. That as the standards evolve, some of these issues may disappear and other issues may appear. And again, remember, these are just a sample. I'm not trying to tell you all the problems that you've got to overcome, just give you an indication of the types of problems you're going to have to overcome. Okay, now what I'm showing you here is data from the old standard, 1388 2B or 0060 part 0. They're both pretty much the same. And this is one of the tables, the BA table in this case. And within that table, you can see there is a parameter which is the authorized life. Now you can see there's an old, this gives you an idea of how out of date Deaf Standard 0060 Part 0 is. As I said, it was cancelled in 2010. It's referring to AECMA. AECMA was the precursor to the ASD organisation, and it refers to things called text element identifiers, which are pretty much now gone and been replaced by XML names, although they are kind of still lurking in odd corners of the latest version of S2000M. So basically, here it is. This is a measure you'd expect to see authorised life of a billet kit, of a part, a provisioned item, and the measurement base, so the 2 paired attributes there, data elements in this case. So what have we got? What's the equivalent of that in S3000L 2000M? Okay, what we're going to look at first then is S3000L. I said duplication here, so what we're going to see is that this something similar to that authorized life appears in S3000L and in 2000M. So here we've got this unit of functionality, and I appreciate it's a lot of detail on your screen here, but bear with me. And this unit of functionality is called part definition. So just bear that in mind. And then down here, what we've got is a one of these case, another attribute group, basically an extension of this box here. We don't worry about the detail too much, but it's an extension of that. It's a list of data of attributes, as I said before, the rough equivalent of a data entry in there. And we're going to look at that and look at the name. If you can see it, I'll expand it in a moment. Hardware part as design data. Oh, it's a bit of a mouthful. Hardware part as design data. And don't forget that unit of functionality part definition. So now I've expanded that particular case there, so you can see it in a bit more detail. And what we're looking at here is this particular attribute, and just say, bear this in mind, hardware part operational authorized life. So I'm asking you to remember three things here: UOF part definition, hardware part as design data, that's the name of the attribute group, and the name of the attribute, hardware part operational authorized life. Okay, so now we've moved into S2000M. I'm looking at another unit of functionality within S2000M standard. And the name of this one is, you probably can't read it here, but it's here for you, part definition data. Remember S3000L, which is part definition. This is part definition data. And we have an attribute group, hardware part as design data. No, that's the same name as the previous one. And again, I'm going to expand that one in a moment so you can see what is going on within it. So the bit we're interested in is the bit at the bottom down here, and you can probably just about make out on your screens that it's got a attribute here, hardware part operational authorized life. And here I've expanded that box so you can see it, hardware part operational authorized life down here, and some other sort of lifing, sort of shelf life and so on as well. But what's the point of this? The point is that you've got two units of functionality with almost the same name, one in S3000L, one in 2000M. You've got an attribute group with the same name, hardware part as design data, in both of those standards, and you've got attributes with the same name, or pretty damn close to the same name, which is the authorized life. And here's the question, and that is, where do you put the actual authorized life? Are you going to put it in S3000L against a part, or are you going to put it in S2000M against a part? And are you going to put it in both? If you're going to put it in both, how are you going to make sure that those two data elements remain in sync? Are you going to maintain configuration control across the data? Nothing. It's not possible to do. It's just something you need to think about and decide how you're going to manage going forward. And in a similar vein, not quite the same, what we find is there are inconsistencies as well between the data standards. So again, we're going to look at S3000L and S2000M at two attributes which you'd expect to be the same, but aren't. Okay, so I'm starting this again. I'm back in 0060 part 0, and I'm displaying something which, again, I'm sure some of you are familiar with, the idea of a thing called an item category code. Now, this is just a code which you put alongside a provisioned item, spare part, or a piece of test equipment or a piece of support equipment to identify basically what it is. It's a form of metadata. And these are the codes which are in, say, 0060 part 0. And what I've done is I've highlighted here in sort of red and bold all those codes which are associated with some sort of support equipment. So you can see the sort of classic examples, common tools, peculiar tools, common test equipment, and so on. So basically a series of codes which we've used to identify what is a provisioned item. Is it a spare part? Is it a manual? Is it a consumable? And so on. Now, the problem occurs when we look at the new S-series specifications. And basically what we've got is two very similar coding type approaches in S3000L and in 2000M. You can see, excuse me, in S3000L, we have a unit of functionality called hardware part as designed support data, and in 2000M, we have a unit of functionality called hardware part as designed support data. In S3000L, there is an attribute called hardware part logistics category, and in 2000M, it's called hardware part provisioning category. Very similar, I'm sure you'll agree. Now, these are the codes. And again, I've highlighted in both cases the codes which relate to identifying whether something is a piece of support equipment or not. There are other things, are they spares or repairables and so on. But here you go. So in X3000L, we have a code which is HT for a standard hand tool. As you can see, it's also there's a common data model dictionary as well, which is what that reference is there. And you've got SE for a piece of support equipment. But if we look at S2000M, we can find that we've got AG for a piece of support equipment, we've got ST for a standard tool, and so on. So basically the codes are not the same. So again, can you get around this problem? Yes, probably. We're doing a bit of XSLT transforms to transform the data as you export from, let's say, 3000 into 2000. But you do have an issue that, again, something you're going to have to take account of and address if you're going to apply these standards. Now, I could go on with a range of different, lot more examples than the ones I've just given you, but just be aware that within the specifications there are errors, actual errors, I believe. There are also problems with software availability. I kind of mentioned earlier in the presentation that the software houses have problems keeping up with the changes in the standards, and they're wary of investing very large sums of money in developing an application if in 2 years' time the data standard is going to change and render their application obsolete, potentially. So software availability is a problem as well. Not for 1000D, because that's been around for a long time and used extensively. There are limited options for 2000M, and people are developing stuff for S3000L, but it's it's taken a long time, and I'm not aware of any organisation that is using an S3000L LSA database in anger yet. If anyone knows, by all means let us know. And 4000 P, which is for schedule maintenance analysis, 5000 F, which is for feedback, and 6000 T, which is for training, are all relatively new standards. And again, I'm not aware of anybody who has developed any software, certainly not on the open market, that you can use to apply these standards. The other thing is as well, if you look at the various aspirations that we've got in the industry, there is a desire to implement this idea of the digital thread. This is where basically data flows from application to application in a fairly seamless way, and in particular where data will flow from the development phase type of applications into the in-service phase applications, maintenance management systems, configuration control systems, supply support systems, and so on. And typically that interface is a challenging one at the moment. But if we get the digital thread right, things will flow across those divides much more easily. That's something we need to be aiming for. Now, the point of this particular list is that the S series do not attempt to address them as yet. The other one is the idea of the digital twin, a good and laudable idea. And what we really need is digital twins to facilitate the application's effective support engineering, ILS or IPS, whatever you want to call it. And in particular, we want a digital twin, I believe, and they don't have to be fancy digital twins for us. We don't want 3D CAD models you can walk through and stuff like that. We just want damn good data definitions of our systems. And in particular, what we need is something which will define the support system. I mean, the support infrastructure. One of the tasks which has always been in the LSA standards from almost since their inception is that you've got to design a support system, but nobody's ever developed a piece of software or an application that enables you to capture that support system definition. I don't think it's particularly challenging technically, to be honest, but it's never been done, apart from Aspire's homemade access databases, which attempted to do that. The other one, again, is this idea, and this does appear in the latest SAE standard, TA standard 0017 alpha, which defines the LSA process, is the idea of an integrated data environment, an IDE, or an integrated rich data platform, or whatever term you want to use. And the idea here is that you cannot You cannot capture all the data and manage all the data that we need to manage in a single database, an LSAR or LSA database. What you've got to do is you've got to look at a range of different applications, and you've got to look at the data contained in each one, and you've got to basically manage that bigger picture. And essentially what you want in the ideal world is the data will be federated. And what we mean by that is the data may be in lots of different places in different applications, but to a particular user who's using that data for a particular purpose, support engineering, configuration management, and so on, it kind of looks like it's a single database, though in reality it may be scattered in different platforms and different physical locations as well. So that's really where we ought to be trying to move to now, an integrated data environment. And what we do not want to be doing, by the way, is exporting data from one application, transforming it and loading it into another application. So you've got basically got the same data in two different places with all the configuration problems that brings. Ideally, we want to put the data in one location. Old adage, create once and use many times. You do not want to be copying the data to different locations. And of course, all of this makes this problem of transitioning, because that's what we're talking about. How do you transition from ILS to IPS, from old standards to new standards? Makes it a bit of a challenge. And here, this kind of sums up the problem. So, apologies for the limitations of artificial intelligence, which was used to create this picture, but it kind of sums up where we are. There's an awful lot of people who think this is a good idea and we ought to move forward, and they all think somebody else should move first. So nobody's willing, if you like, to jump in the water, because basically you're almost guaranteed to get hurt. We need pioneers. We need someone to pioneer moving towards a proper integrated data set using the S-series specifications. But it's the old joke, isn't it? How do you recognise a pioneer? They're the ones lying face down in the track with arrows in the back. People are wary, and rightly so, about moving forward. So we really need some organisation, large organisation with authority to drive this forward. Now, my personal belief is that can only be done almost at a government level. It's got to come from the Ministry of Defence or Strategic Command. It's got to come from a very high level. Individual organisations are probably not going to do this, even very large ones. I've talked to people in large prime contractors, and typically their response is, well, we'll move when we're told to, basically when it's a requirement in a standard, in a contract, and then we'll move. And basically what that also means is, of course, is when they're funded to move, then they're not going to do this on their own bat, because you could spend a huge amount of money and find out that you've gone charging forward and no one's followed you, and you're basically on your own, and your money's being wasted. And there are examples of that already in the business, in the defence sector. So what am I suggesting? Am I suggesting that we don't do this? No, I'm not. What we're actually suggesting, and what we've suggested on a major project, was that yes, you should move forward with the S series, and you use the data models, the many data models that are in the S series, as a foundation for a support engineering data model. And that's what this means on the top of the screen here, support engineering data model. And the way you do that is you define it. You've got to do it in a logical, structured way. So basically, define two things. Define what output you want, and I appreciate, again, you can't see this diagram, but this is a real working diagram that we started to build up for a particular project, where you define all the outputs that are required. And those outputs are, if you like, project deliverables, like reports and so on, and also the evolving product, and that's what these coloured blobs are along the bottom. The platform definition, the support system definition, the employment plan definition, evolving over time until you end up with a solution which is deployed and managed during the service phase. So what are the outputs, and what data do you need to describe those? And then, of course, the processes. What are the processes in each phase of the life cycle? You probably just about make out with some duplication here. What processes are applied, and how do those processes vary in each phase of the life cycle? The processes which generate these outputs, and what data do they need? So if you're doing Formica, what data do you need for Formica? If you're doing RCM, what data do you need for RCM? If you're producing a maintenance plan, what does the maintenance plan look like? What's the technical publication look like? and so on in data terms. And also we've got to look at this, and we've got to think about the digital twins and digital threads idea. Because what if we're going to define a support infrastructure, then can we make a digital twin of the support infrastructure? And that would be quite useful in the in-service phase, support this idea of model-based systems engineering or model-based support engineering, if you like. And also we can make sure that the data flows through the lifecycle, and that these products evolve in a rational, structured way over time. So basically, we need to be taking into account digital twins and digital threads when we're looking at our data. Our preference is to base those processes on the processes or the activities which are defined in the SE standard TA standard 0017 alpha, which is basically the successor to 13881A and Def Standard 0060 Part 1. And it defines the processes as a series of activities, or tasks if you prefer. And that's a nicely structured document. And there's some guidance coming out on that shortly. There is a guidance handbook 502, which has been updated to reflect basically the alpha version of this. So we use that as the basis of this, but also included reference to other standards like ISO 15288, systems engineering standards, and even a dash of Prince 2 projects and controlled environments scattered in there as well. So that way, if you end up, then you basically can use the S-series data elements, the data elements of the data models, where they're appropriate, and where they're not, don't ignore them. And where you need to fill in the gaps and come up with your own support engineering data model. That's essentially the concept that we've been promoting. However, there is still a vacancy for that leadership role, because somebody has to drive this forward. Some organisation has to drive this forward. Otherwise, personal belief is it will never really happen. And at the moment, I think our instinct is it's actually the smaller nations which are leading the charge on this, as opposed to the bigger players like the US and the UK. Okay, so there is still a vacancy for that leadership role, which, as I've said before, I believe needs to be at sort of government MOD level to make it viable. Okay, ladies and gentlemen, that's the end of the presentation. I've put questions up there. That was on the original slide pack. Obviously, you can't ask questions if this is just an online video, but by all means, don't be afraid to contact Aspire or myself personally. If you've got any questions about this or anything you don't agree with, you want to, if you argue in the classic sense of the word about what I've said and what I've presented here. I said, but don't be afraid to connect with us and contact us if you've got any questions or you want any more detail about any of this. Okay, thank you very much, and bye for now.